we have uncovered a remarkable planet, a world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth, and we are only beginning to unlock its secrets. Deep within the superheated core of this planet, spinning molten metal creates an invisible shield that covers the entire globe. This is the Earth's magnetic field, and the planet's shield is under attack.
The Earth's magnetic field has declined in strength about 10%.
If a large solar flare hits the planet Earth, it can throw us back perhaps 100 years into the past.
And the whole thing can have this cascading effect that can spell utter doom to society.
And there's a disturbing secret. Deadly solar flares are increasing. On Secrets of the Earth. Imagine it is night. Tomorrow, the aurora borealis appears across the northern part of the planet, dazzling millions in the cities of New York, Chicago, Seattle. Auroras are the only visual sign that this planet has a protective shield, a magnetic shield generated at the planet's own liquid metal core. But there's a disturbing secret about the planet's magnetic field.
Right now, the Earth's magnetic field is getting weaker and weaker. And if a gigantic solar flare comes at us, we don't have this shield anymore protecting the planet Earth.
Auroras don't begin on Earth. They are the result of a solar flare, a mass of plasma that explodes from the sun's surface, carrying its own magnetic charge. When the auroras appear, the inhabitants of Earth might find them beautiful. But there's an ugly secret behind the beautiful display. 90 seconds after the auroras appear, every city in America could go black.
If a large solar flare hits the planet Earth, it could literally wipe out all our satellites and power plants and throw us back perhaps 100 years into the past.
The magnetic charge in the solar flare could overpower and burn out the North American grid. Transformers could explode in every major city. Power shuts down. Communications are crippled. Civilization nears collapse.
Hundreds of high-voltage transformers could be blown out permanently. So imagine much of North America without power. It's estimated that 130 million people could be affected by this directly.
The estimated cost would be $2 trillion. That is 20 Katrinas, 20 times worse than Katrina, and it would be global rather than local.
This is the deadly power of a solar storm. In fact, it has happened before, with disastrous results. On March 9, 1989, a coronal mass ejection hit North America, temporarily destroying the power grid of the entire Canadian province of Quebec due to a blast of magnetism from the sun. The entire planet and its civilization is shielded only by the Earth's geomagnetic field and the simple power of magnetism.
Magnetism is this really interesting force that occurs when the atoms of certain types of metals are aligned with each other. So here I have two horseshoe magnets, and each of them has a north pole at the top and a south pole at the bottom. When I hold them together like this, the north poles repel each other and the south poles repel each other. The magnetism associated with little magnets also exists on a very large scale. The Earth can be thought of as one gigantic magnet with a North Pole and a South Pole, and the magnetic field lines spreading out around it.
As charged particles in a solar flare meet the magnetic field lines of Earth, they are deflected and flow safely around the planet, usually. Humanity monitors the Earth's magnetic shield and the threats from solar storms at a location high in the North American Rocky Mountains, at the Space Weather Prediction Center.
Just as we have our National Hurricane Center for storms that everyone is familiar with, we have a Space Weather Prediction Center as well. So there can be hurricanes in space. The sun is exceptionally complicated. It's essentially a huge, giant burning ball of superheated gas or plasma, a churning thermonuclear furnace. And these moving plasmas create magnetic fields, and on occasion, these fields will make their way to the surface and poke through, essentially. And that's what we see as a sunspot.
Hi, good morning, everyone. I'm going to get started. So welcome to the 9:10 briefing.
Here inside the Forecast Center at NOAA's Space Weather Prediction Center, researchers watch the sun 24 hours a day from an array of different satellites. There is a daily briefing every morning on the sun's activity.
And forecasting probability of M-class flare at 40% both for today and for the next 3 days.
There is a radio alert broadcast around the world every afternoon.
No space weather storms were observed for the past 24 hours. No space weather storms are predicted for the next 24 hours.
The reason for this constant vigilance is both scientific and practical. A solar flare, or coronal mass ejection, can sometimes be large enough to overwhelm the planet's magnetic shield.
A coronal mass ejection is potentially harmful to life, to us here on Earth. The magnetic field from the coronal mass ejection can induce currents in large power lines that can blow out transformers and cause widespread blackouts.
And so the Earth is, in some sense, in the middle of a shooting gallery, with the sun shooting these gigantic flares into outer space from the sunspots.
The only thing preventing the deadly impact of coronal mass ejections is the Earth's magnetic shield. Impacts from coronal mass ejections are relatively rare. The sun has an 11-year sunspot cycle. As the cycle reaches its peak, solar flares and coronal mass ejections become a much greater threat.
Yeah,
When a solar flare begins to grow, the team at the Boulder Prediction Center takes notice.
Yeah, it's getting pretty good sized.
Yeah, it's looking rather gnarly if you ask me.
Some scientists predict that the chance of Earth being hit by a catastrophic solar storm in the next decade is 1 in 8. And the secret that few scientists discuss is that Earth's magnetic shield is gradually getting weaker, and solar storms are getting stronger. The sun can fire thousands of tons of superheated, magnetized plasma in solar flares and coronal mass ejections. The only thing protecting Earth is the planet's magnetic shield. But there's a secret danger that few scientists acknowledge. Earth's magnetic shield is changing and getting weaker.
Earth is not a permanent magnet. It creates its own magnetic field because it's a dynamo. There's circulating iron in the core, which creates a current, which produces a magnetic field. In a similar way, I can spin this flashlight, produce a current, which charges a battery, which then causes the light to glow. This is a dynamo as well, much like the Earth.
Scientists have struggled to study this ocean of underground metal and its magnetic field. Part of the problem is that it's nearly 2,000 miles underground and 8,000 degrees hotter than the surface. But scientists at the University of Maryland may have cracked the case. Here in the bottom floor of a windowless lab, Dr. Daniel Lathrop has built a model of the Earth itself.
So we've been building a sequence of experiments trying to match parameters with the Earth's core to try to better understand how a planet generates a magnetic field. The latest experiment is a 10-foot diameter rotating mimic of the Earth's core.
This giant steel sphere is filled with 11 tons of liquid sodium surrounding a solid core, just like the liquid iron and solid core at the center of planet Earth.
On the outside of the sphere is an array of about 30 Hall probes that are little electronic devices that measure the strength of the magnetic field coming out from the sodium. This device took us about 10 years to design and build, and we're within our first year of running initial sodium experiments. Let's take it for a spin.
Here we go. All right, and we're starting up.
When the 10-foot sphere begins to rotate rapidly, the sodium will generate a magnetic field nearly identical to Earth's.
Every 3 seconds of the experiment mimics on the order of 15,000 years of a planet's evolution. So by doing even a day's worth of experiments, we have a very long time record of how a planet might behave.
One surprising result of this study reveals that the sphere's magnetic field is not stable at all. In fact, it wobbles, weakens, and even flips completely. Geological studies show that the same thing has happened to the planet at large. Rocks buried deep in the Earth's mantle reveal that the poles flipped nearly 800,000 years ago, and again 10,000 years before that.
So the last reversal has been a little less than 1 million years ago, but we've seen changes in the Earth's magnetic field suggesting we could be headed for a reversal.
Research suggests that Earth's magnetic field reverses polarity roughly every 500,000 years. The problem is, a reversal is long overdue.
What is likely is that during a time of reversal, this protective shield of the Earth, the magnetosphere, is likely to shrink in size. And so then the area of space around the Earth being protected would be less. In particular, over the last 150 years or so, the Earth's magnetic field has declined in strength about 10% and continues to decline in strength every time people go and make new measurements.
Our magnetic field protects the Earth. However, as the magnetic field begins to dampen and as the North Pole begins to migrate, there could be more radiation coming down from the sun. And if a gigantic solar flare comes at us, we don't have this shield anymore protecting the planet Earth.
The Earth's magnetic shield seems to be weakening, and the sun's 11-year magnetic cycle is revving up. 150 years ago, a gigantic solar flare actually hit planet Earth. If it hit today, how much damage would it do as it destroys the power grid of an entire continent? A planet-wide magnetic shield is the only thing that stands between the Earth and blasts of ionized plasma from the sun. But there are times when that protective shield doesn't work. 1859, a British astronomer named Carrington notices a large solar flare. It is so powerful that 2 days later, it sends an electromagnetic wave across the face of the entire planet.
So aurora for the 1859 storm was visible essentially near the equator. So you think about Samoa, even in Panama, there's reports of campers in the Rocky Mountains waking up and starting to cook breakfast because they thought the sun was rising. So really spectacular aurora across the globe and visible from most of the globe.
The Carrington event caused telegraph lines across America to short out or burst into flames. But in 1859, electricity was a rare phenomenon. The gigantic Carrington solar flare had little effect. In today's interconnected world, the same type of solar storm would do more than create auroras. It could create an apocalypse.
If a Carrington-sized event were to hit North America today, the cascade of collateral damage is enormous.
Imagine it is tomorrow. While you sleep, while the sun is on the other side of the Earth, Men and women still monitor its surface at the Space Weather Prediction Center. They see a coronal mass ejection erupt from the sun. It is 100,000 miles across. It contains the destructive power of 10,000 nuclear weapons. And it's heading straight toward Earth.
Traveling anywhere from 1 to 5 million miles an hour, it makes that 93 million mile trip in just under a day to several days.
The satellite belt gets the first blow.
The GPS system can be disrupted, telecommunications can be disrupted, all kinds of things start occurring on Earth because we so much depend on our satellite system these days.
Minutes later, the solar storm hits Earth's magnetic shield and overwhelms it. The first sign, lights in the sky. As the skies light up, darkness falls across an entire continent.
If a huge coronal mass ejection were to hit, this whole power plant could be fried in just a few seconds.
Electrical lines turn into antennas, overloading transformers across the northern hemisphere. Power goes out everywhere.
Telecommunications will go down, the internet will go down, TV, radio, GPS, weather satellites will all be wiped out. Then power stations will be short-circuited.
There is nowhere to get backup power. Generators will only last until they run out of gasoline. But without power, gas stations will not be able to pump.
It means that food riots will take place in a few days because refrigerators are going to go out. Commerce will come to a halt. Credit card transactions, transactions between banks, all of that will be wiped out.
Power, water, transportation, banking, and medicine all collapse. There will be no electricity, no telephones, no food deliveries, no working hospitals, no running water for 3 months, 6 months, a year, even longer.
In this worst-case scenario, it may take years to recover. Because if you have a localized hurricane, a localized storm, there's help from the outside. The rest of the world is not affected. Here we're talking about the entire planet being affected by a gigantic superstorm.
So far, the power of the Earth's magnetic shield has saved humanity from this fate. As the Earth's magnetic shield weakens, the threat from a magnetic apocalypse grows. But there are some on Earth who not only watch for the next blast from the face of the sun, they intend to do something about it. The Earth's magnetic shield may be the only thing protecting the planet from the deadly effects of a solar flare or coronal mass ejection. And it may not be enough.
If there's a really major blast that comes our way, the reaction times are simply not fast enough. And that's when hundreds of transformers might get blown out with truly devastating consequences for life on Earth.
The inhabitants of Earth are not completely helpless. As studies reveal the true power of solar storms, they also reveal what can be done to protect the planet.
We physicists went to the United States Congress last year, and we asked them for chump change, a few $100 million to reinforce power stations, build backup systems, get an early warning system off the ground, and take certain protective measures for our astronauts and our satellites.
So far, federal funding has been scarce. Perhaps most importantly, scientists are doubling their efforts to understand and monitor the star that resides at the center of our solar system.
The real hope is that experimental data from a device like this can be used together with computer models to build a more predictive science of the magnetic field and give us then predictions on an annual basis.
And liftoff of the Atlas V with the Solar Dynamics Observatory.
NASA launched the Solar Dynamics Observatory satellite in 2010. It watches the sun's magnetic fields with 4 different imaging lenses, covering 10 separate wavelengths. The Space Weather Prediction Center continues to keep its eye on the sun. But that may not be enough.
The problem is we're very young in the space age. We've only had satellites in orbit for 50 years. That's nothing. Each solar cycle is 11 years. We've only gone through 5 solar cycles. And so we have very little experience with monster storms from outer space as a consequence.
The sun is a thermonuclear furnace, 865,000 miles across. The Earth is a tiny hunk of rock with a thin layer of biology.
So far, we've dodged the bullet. One of these days, however, one of these bullets is going to hit the Earth.
In a throwdown between the all-powerful sun and the Earth usually wins, saved only by the power of its magnetic shield. The question is, for how long?